Determine which of the two acute angles has a sine of 4/10. So find the sine of angle Q and the sine of angle R. So the sine of angle Q is equal to the length of the opposite side to angle Q divided by the hypotenuse, which equals the quantity 3 times the square root of 21 divided by 15, or the square root of 21 divided by 5, which is approximately 9,163 ten-thousandths. And the sine of angle R equals the length of the opposite side to angle R divided by the hypotenuse, which equals 6 divided by 15, or 2/5, which equals 4/10. The acute angle that has a sine of 4/10 is angle R. Let angle A, angle B, and angle C be acute angles. Use a calculator to approximate the measures of angle A, angle B, and angle C to the nearest tenth of a degree. Part A. The tangent of angle A equals 3 29/100. So the measure of angle A equals the inverse tangent of 3 29/100, which is approximately 73 1/10 degrees. So the measure of angle A is about 73 1/10 degrees. Part B. Sine of angle B equals 55/100. So the measure of angle B equals the inverse sine of 55/100, which is about 33 4/10 degrees. So the measure of angle B is about 33 4/10 degrees. Part C. Cosine of angle C equals 87/100. So the measure of angle C equals the inverse cosine of 87/100, which is about 29 5/10 degrees. So the measure of angle C is about 29 5/10 degrees. Solve the right triangle. Round decimal answers to the nearest tenth. In order to solve the right triangle, you need to find the measures of angle A and angle C and the length of line segment AB. So let the length of line segment AB be C. Because this is a right triangle, you can use the Pythagorean theorem, which says that c squared plus 24 squared equals 25 squared. Simplifying gives that c squared plus 576 equals 625. Subtracting 576 from each side gives c squared equals 49. Then taking the square root of each side gives c equals 7. Next, find the measure of angle A. Again, because this is a right triangle, you can use the tangent ratio. So the measure of angle A equals the inverse tangent of 24 divided by 7. Using your calculator to solve gives that the measure of angle A is about 73 and 7/10 degrees. Then because angle A and angle C are complements, the measure of angle C equals 90 degrees minus the measure of angle A. Substituting in the value for the measure of angle A gives that the measure of angle C is about 90 degrees minus 73 and 7/10 degrees. So the measure of angle C is about 16 and 3/10 degrees. So you have solved the right triangle. Solve the right triangle. Round decimal answers to the nearest tenth. To solve the right triangle, you need to find the measure of angle y and the lengths x and y. Begin by finding the side lengths of the triangle. So the sine of x is equal to the opposite side over the hypotenuse. Then plugging in the given information from the diagram gives the sine of 41 degrees equals x divided by 18 and 4/10. Multiplying each side by 18 and 4/10 gives that 18 and 4/10 times the sine of 41 degrees equals x. Then using your calculator to solve gives 12 and 1/10 is about x. Next, find y. So the cosine of x is equal to the adjacent side over the hypotenuse. So plugging in the given information from the diagram gives the cosine of 41 degrees equals y divided by 18 and 4/10. Then multiplying by 18 and 4/10 on each side gives 18 and 4/10 times the cosine of 41 degrees equals y. Using your calculator to solve gives 13 and 9/10 is about y. Now find the measure of angle y. Because angle y and angle x are complements, you can write the measure of angle y equals 90 degrees minus the measure of angle x, which equals 90 degrees minus 41 degrees, or 49 degrees. So the measure of angle y equals 49 degrees. Your school is building a raked stage. The stage will be 25 feet long from front to back with a total rise of 1 5/10 feet. You want the rake to be 5 degrees or less. Is the raked stage within your desired range? Explain. Because the stage forms a right triangle, you can use the sine ratio to find x. So the sine of x is equal to the length of the opposite side divided by the length of the hypotenuse. Looking at the picture, 1 5/10 is the length of the opposite side, and 25 is the length of the hypotenuse. So substituting in this information gives the sine of x is equal to 1 5/10 divided by 25. Solving the equation for x gives x equals the inverse sine of the quantity 1 5/10 divided by 25. Using a calculator to solve gives x is approximately 3 4/10 degrees. The rake is about 3 4/10 degrees, so it is within your desired range of 5 degrees or less.